In this problem, we're going to be looking to try to solve the differential equation 2xy and dy dx is equal to 4x squared plus 3y squared. All right. So a differential equation in this form, you might try dividing by 2xy and see if it becomes either separable or, an integrating factor kind of form. But it looks like if we try those methods, we actually don't get a result that is in a form that's simpler. So um, in that regard, then we're going to try a substitution of the form y equals v times x. Okay. And this may seem out of the blue, but a good hint or a good idea to try at least is if you see mixed terms like these mixed values here, especially in front of the differential, that's a really good indication that the substitution of this form may be very helpful in transforming the differential equation into a form that is something that we know how to solve. All right, so let's try that out. And if we do that, then we know that dy dx is going to give us something of the form v plus x dv dx. This is using the product rule. Okay. And you'll note that y can be written over x can be written as v. Okay, just dividing both sides here by x can give us this. And so that allows us then to see if, as we divide through the terms here, if that allows us to simplify anything. Or another way of saying that is 1 over v is equal to x over y. So just different forms to pay attention to help you do some of the algebraic manipulations to transform this differential equation to something a little bit maybe more useful. Okay, so if we plug in our results here, okay, let's see, we have 2xy. Well, xy is 2xy, so that's 2v dy dx. Well, we already saw that that was v plus x dv dx is equal to, well, we saw that 4x squared x is equal to uh, x is equal to, let's see, what do we have? We have y over v. And so we'd have to square that with a 4 plus, and then a 3, and then we'd have to square that as well. So it looks like it might be actually easier, instead of trying to plug in directly here, what if we stop for a second and recognize that we can divide out by this coefficient to get dy dx by itself in the first place? Maybe that'll be simpler because I have a product here and a bunch of the substitutions can require a mix of things. So it might be easier to do that first. Let's try that and see what happens. So if we do that, we're going to get dy dx is equal to the 2 divided by 2 is going to give me a 2x squared. So this is going to give me an x over y, and then plus 3, and then the y is going to cancel, and you're going to get a y over x. And so this form with these observations make this substitution a much easier process. So sometimes it's helpful to divide out by the coefficients or the functions here and simplify that way. Sometimes it's helpful to plug in directly and see what you get. So this way I could see it was going to get a lot messier to make the substitution. So I thought before I go further with that, maybe I should try plugging in and see what we get. So let's take this value here and rewrite it. So dy dx. Well, we saw over 2x. So I forgot the 2 here. This is going to be a 2 down here. Don't let me forget that. X over y plus 3 over 2y over x. Okay. So this we know from here is going to be v plus x dv dx and that's going to equal 2 over, let's see, 2 over, not 2 over, sorry, 2 times x over y. Well, we saw x over y is really equal to 2 over v plus, and then we have here 3 halves, and that's y over x. So that is exactly v. Okay, sorry about that. All right, so there is our the values that we're looking for. And so let's see what we can do to clean this up. So let's maybe get a common denominator here and see if anything simplifies it. We can also subtract over maybe that term there. So what do we have? We have x dv dx is equal to, it looks like we have, hmm, it looks like we're going to have, well, if I subtract a v here from this v, this is 2 over 2 v's, and this is 3 over 2 v's, so that's going to give me a 1/2 v, so that's going to give me 2v plus, looks like v over 2, 1v minus 3/2 v is going to give me a half v, or 2 v's subtracted, so those are going to cancel out because they're like terms. And let's see, if I get a common denominator from there, I'm going to get, what, v squared plus 4 over 2v, and then an x. So that looks like it's separable at that point. I can move the x and dx over to this side and then divide everything over through on that side. So this gives me dividing it 2v dv, the denominator here, over, looks like 4 plus v squared. The numerator becomes the denominator on this side. And that's going to equal, looks like dx over x on the side. So invert that and multiply. Okay, which is really nice because the integrals on both of these are going to be pretty simple. This is going to be a simple u sub. So if we let u equal 4 plus v squared, then du is going to equal 2v dv, which should be exactly the numerator. So that's very nice. And this is going to be a simple integral of the 1 over x, that's a natural log. So if we integrate that, we're going to get the natural log of v squared plus 4. I'm neglecting the absolute values here because this quantity is always positive for real numbers, and that's going to equal natural log absolute value of x plus some constant. So that's the integral. Let's see. Now we need to do something to get the, looks like the v term by itself, and recognizing that these are both natural logs. So I'm going to exponentiate these with the derivative or with the inverse function. So those are going to do each other. And that makes this a little bit easier. It's going to be squared plus 4 is equal to like absolute value of x. So an absolute value of x. And then this is e to the c. Just separating that, it's going to be e to the c, so that you can think of it as like this because of the addition here. It's going to be a product. And so that becomes a constant here. So I'm going to call this a new constant, just c. But the c here is the e to the c from here, just for clarity's sake. And then it looks like we subtract that 4 over, and then our v, remember, was y over x. So let's do that. It's going to be y over x squared is equal to the absolute value of x times c minus 4. And then last but not least, it looks like I could simply multiply everything through by the x squared term here. And I would get at least y squared is equal to, this is x times x squared, so this is going to be x cubed, dropping the absolute values for simplicity's sake, times the constant. So I'm going to write that constant in front now, minus 4x squared. So there's a little bit of an agreement with the value of the sign here, so just be careful about that. So that's y squared is equal to this, and so depending on the initial conditions, that will change the direction of whether or not this is if I take the square root, a positive square root or negative square root of this function for x. right? And so that's it's not explicitly defined in terms of y equals, but it is explicit in terms of it's the square of the y, right? I hope that was helpful, and I'll see you in the next video.